Hi, I'm Michelle Stuhlmacher, a PhD student at Arizona State University, part of a great team crossing a lot of institutions that's looking to map global urban areas. So over 50% of the world's population is urban, but right now a lot of the data sets that we can use to understand urban extent are either limited in their spatial extent or their temporal extent. Like MODIS is across the whole globe and through time, but it's got not as high of a spatial resolution as Landsat, for example. And then if you examine urban areas for your research, you might have a really high accuracy image for your city, but you don't have it across a global area. And so our goal is to use data-driven classification methods on Landsat imagery to create a time series of built-up areas across the globe. All right, I don't have a lot of time to talk about our classification methods, so I'm just going to talk about some of the innovations. Besides the ones that just come with using Google Earth Engine, we're using kind of a simple form of transfer learning in which we threshold nighttime lights at a certain level and then take those as our training to put in the random forest classifier. And so those, along with all of the Landsat bands and indices, are what process it. We also mask out vegetation and water bodies before they go into the classifier, and then we're running our classifier over a variety of scales. And we're using hexagons because they match up nicely over a like circular surface like our globe. And so we're testing kind of the local variation with the hexagons. Something that's more similar on a small level will have higher accuracy there, whereas maybe a whole desert would have a lot of similarity across that larger hexagon. And then these are results from our first paper that we're in the revise and resubmit process of. This top row is our methodology, and the bottom row is nighttime lights. You can see that we have a little more clarity because of the 30-meter resolution. Oh, sorry, this is MODIS on the bottom. And so we started our analysis in India, the United States, and Mexico, and so that's where those three are. And then this is why I got ahead of myself. This is our classification compared to nighttime lights. And so you can see, again, the like greater crispness, and then because of a lot of the downsides of nighttime lights, we only use those as like our training, and that helps with more crisp classification. It's a big project, so we've started with those 3 countries. We're also working on generating a global validation data set with digital globe/TomNod, and then we hope to run the algorithm globally through time and make that data set available in Google Earth Engine.
Which years are you processing? Like, is it just a current year, or how fast are you
we're using nighttime light data that goes back to 1992, so hopefully it'll be 1992 through present. Right now we're starting with the early 2000s.